Here we've been asked to graph f of x equals 2e to the 0.24x. Now, I know some things about graphs. One, I have a base that's 2.7, which is greater than 1, and a positive exponent. So I know I'm going to have exponential growth. So my graph is going to go up like that. Outside affects the y. I'm going to have a vertical stretch by factor of 2. Inside affects the x, and it's crazy, cuckoo, bonkers, bananas. So a 0.24 is actually going to be a horizontal stretch. But essentially, even with a horizontal stretch and a vertical stretch, I still will have a graph that goes up, up, up. I took the liberty to graph some points. I plugged in -3 for x, then -2 for x, then -1 for x, then 0 for x, then 1 for x, then 2 for x, and 3 for x. And I got these values. So come on along, let's graph these values. Here's my y-axis, or x equals 0. Here's my x-axis, or y equals 0. I have this point 0, 2. Wait a second, I thought the magic point was 0, 1. Oh, it is. But I've got a vertical stretch by factor of 2, so it took it from here and on up. If I go to 1, I'm going to go over 1 and up 2.54, over 2 and up 3.23, over 3 and up 4.11. If I go the other side, to the left, -1, I'm 1.57, -2, I'm 1.24, and -3, I'm at 0.97. I'll never reach this 0 line because y equals 0 means I have a horizontal asymptote here. And my graph, just as I expected, goes up, up, up. And here's our critical point, in this case, 0, 2. Because of this vertical stretch by factor of 2. I was expecting 0, 1, but I got stretched 0, 2. So I've asked, here is our point 1, 2.54. When you graph, I've asked for at least 2 points and 1 asymptote. My asymptote is at y equals 0. I've got a point at 0, 2, and 1, 2.54. In another example of graphing these natural exponential functions, let's consider g of x equals 1/2 e to the -0.58x. I know that this is a base greater than 1 up with a negative exponent. That's a perfect recipe for exponential decay. Base greater than 1 with a negative exponent, including a variable, is a perfect recipe for exponential decay. So it's going to be going down, down, down. Not only do we have that negative, which reflects our graph, our growth graph over that y-axis, as we've talked about in 3.1 day 1, but we also have a number there less than 1. Well, I know this is the crazy, cuckoo, bizarro, bonkers world inside this parentheses affecting the x. So that's actually going to stretch us this way. Outside the parentheses affects the y, so it's exactly what I thought. It's going to shrink me by a factor of 1/2. For the values, -3 to 3, just the integers, I took the liberty to go ahead and calculate the values of the g of x function, or in other words, I calculated the y values. Here's our x-axis, here is our y-axis. I have this point 0 over back and forth 0 on the x and up 0.5. Wait a second, shouldn't it be 0, 1? It should be, but we've got this vertical shrink by factor 1/2. So what I thought would be 1 is 1/2 of that. So it's at 0, 1/2. 1, I'm at 0.3. 2, I'm at 0.2. And 3, I'm at 0.1. Now, I rounded these values to 1 decimal place. You certainly could do better than I could. At -1, I'm going to be up a little higher at 0.9. At -2, I'm up a little higher at 1.6. And at -3, I'm all the way up at 2.8. And so you do see this nice exponential decay curve, just what I anticipated by looking at a base greater than 1 and a negative exponent here. You know I want at least 2 points in an asymptote. So this is 0, 1/2. I'm expecting 0, 1, but because of this vertical shrink, I get 0, 1/2. And I'll take this point here at 1, 0.3. And our asymptote here is this one, y equals 0. Notice our values go very close to 0, but even though this one is very close to 0, it's never going to touch 0. It's always going to be above this x-axis, which is the y equals 0 line.